Welcome everybody to today's presentation, which is Conquering Production Uncertainty with Smart Scheduling. I am Phil Glennie and I'm joined here today by Marco Antonio Baptista from Siemens Digital Industry Software. I am from Long-Term Technology Services and we thank you for joining us here today. Here's a little picture of us. As you can see from the top picture, you're looking at a picture of me before COVID hit. Things haven't gone outside in a while, so hence the beard. Marco, I think I saw you earlier this week. You're looking as good as ever, so congrats on that.
I doubt it.
So here's a bit of today's agenda. We're going to go through an introduction, which I'm doing at this moment, followed by a bit of an industry overview to give you a bit of context for the solutions we're going to be looking at and the why behind their creation. Then I'm going to kick it over to Marco, who's going to give us a bit of a solution overview on how we're going to approach smart scheduling. And then from there, we'll see some success stories, hopefully some of which will speak to your use case. And then we'll follow that by a Q&A. And at this point, I'm just going to shut my camera at this point just to make sure I'm not distracting from the presentation. So here's a little bit about us at LTS. So we are a holistic digital industry partner for all of your software needs in digital industry. We really are a one-stop shop of training, software licensing, implementation, consulting, enterprise level strategy, all of those things, no matter what you're looking to do in terms of improving your production efficiency or your production in general. With digital industry solutions, we're there for you. We're talking about design and engineering solutions, your CAD software, optimizing your plant or your automation processes with value-add simulations, or as we're going to see today, getting some big production wins with advanced smart scheduling. We also very much specialize in helping small and mid-sized companies reap the full rewards of digital industry software, some types of solutions that might have previously only been available to very advanced companies. I'm just going to make sure that, everyone's getting let in. Okay, good. And we are a very proud Siemens Smart Partner and Technology Partner, and that's why we're lucky to be joined here today by Marco from Brazil, who is a representative of Siemens and the channel leader for the Manufacturing Operations Management. So I'm going to kick things off here with a little bit of an industry overview to talk about the context behind what we're going to be talking about today. So as you can see from here, manufacturing is on the move. There's a lot of things changing in manufacturing. You're seeing increased demands, a lot of new technologies coming in, but you're also seeing this very strong downward pressure on profit margins. And part of that is the share increase of emerging markets. You're facing growing regulations and safety standards, and you're getting this increasing complexity both in supply chains and in demand for what your products do or how complex your products are. And so you get from that into this growing word cloud of things that people want. And what they want is complexity. They want shorter lead times. They want that for the same price, if not cheaper than what they're used to. And they want things more efficient while they're at it. So that brings us to, well, what are the three that are the most important? Well, the top three pressures when it comes to improving your production are standardization, flexibility, and quality. And today we're going to talk about solutions that speak to all three of those simultaneously, getting them to work together. Getting from there, this is a quote that we really like to share, from Shigeo Shingo from Toyota, which is the most dangerous kind of waste is the waste we do not recognize. Another way of putting this is we do not know what we do not know. And I'm sure many of you as producers know this about your clients, right? It's often they don't know what they don't know when it comes to efficiency improvements, and that goes for scheduling as well. Scheduling is one of the areas where you can actually get your quickest, biggest production wins with the least amount of upfront investment. And we're going to talk about that a little bit today as well. How's that possible? Well, here's two approaches that people really, really like, right? There's the lean approach and there's the agile approach, and it's often posed as an either-or type of proposition. You know, do you want to be fast and efficient, or do you want to be flexible and have higher quality? And with the solutions we're looking at today, the idea here is that you can be both at the same time. And if you put them together, you get Agile. Maybe not the easiest, maybe not the most fun word to say in the world, but it does get to the concept of what we're going to be talking about today with scheduling. So here's a little sort of mental exercise to start with. Scheduling is tough. So let's say you're scheduling 5 operations on a single machine. Just if you want to use the chat window, how many combinations of, how many ways are there? to schedule 5 operations on a single machine when it comes to sequencing? Does anyone want to guess in the chat window? Oh, 5 ways of scheduling. So if it's 5 different operations and you're looking at different ways that the 5 different operations can be sequenced, right? So there are 5 different types of operations and they can be sequenced in different combinations. 5 factorial. Oh, right. Yes, exactly. Which gives us 120 different combinations. Now, the thing is that a company usually has more than a single machine. So what happens if the company has more than one machine? Let's say the company has to schedule 5 different operations across 2 machines. Does anybody want to guess what happens when you try to schedule 5 operations across 2 different machines? Any guesses on that one? All right. Oh, a lot. Yes, Alan. Alan has the correct answer. The answer is a lot. Well, if you're trying to, if you have 2 machines in your shop and you're trying to schedule 5 different operations across those 2 machines, the different ways that you can sequence that schedule is 14,400 different ways. So now consider for a moment how many people do their scheduling with an Excel sheet. Yes, Excel sheets allow you to build very nice formulas, but imagine if there's changes. Imagine if a machine goes down. Imagine if some material arrives late. How in the world are you going to pick a best possible schedule from 14,400 different combinations? Well, I'll tell you, some people will just say, we don't like complexity and we're not going to deal with it. So we're going to build in so much production buffer and we're going to sacrifice so much production that our schedule is just so durable that it will just eat these disruptions. As you just may have just heard, that requires a significant sacrifice in the production you can have. So we're going to look at different ways of approaching that. Now, before I go on, I just wanted to make a quick note about planning versus scheduling. As you can see from this graph, planning is really more a mid to long-term thing. It's often drawn up in terms of buckets of capacity. If you're familiar with production scheduling through an ERP system, this is often how that's done. It's more like, you know roughly what resources are required to accomplish a certain amount of work, and you create these sort of buckets of capacity that you hope will fulfill the work when you assign them. But it's not super specific in terms of assigning specific tasks to specific resources down to the hour, like you're going to see in this chart down here, right? The more Gantt chart view. And then you're talking about projections, right? Projections of demand, how much you're going to make, where you make it. Scheduling is more short-term, and it's based on the real-world resources and the constraints that you're facing on your real shop floor, and then you're sequencing a schedule, as you can see here from a Gantt chart, right? And you're thinking about how best to schedule the real production in the near term and looking at the constraints that you face. And just a quick note here on advanced. So APS here, for your reference, stands for Advanced Planning and Scheduling Software. And advanced planning and scheduling software is distinguished from spreadsheets like Excel, and it's distinguished from using ERP, an enterprise resource planning system, to do your scheduling. Versus a spreadsheet, one big thing is scenario analysis, as we'll see in a bit, right? So an APS solution allows you to perform a lot of what if analyses. You can look at what happens if we bring in a new order that's just going to eat resources and it's prioritized for a very high priority client and it just needs to bump other things. How's it going to affect overall production? How many people do we have to inform that their orders will be late, or how many of those orders can we reschedule around the new order to make sure that they are not late? Customers and suppliers input handling. So in other words, if one of your suppliers, right, comes to you and says, that material you need, you're not going to get that this week, it's coming next Tuesday, how is that going to cascade through your production schedule? Can you do that? Can you immediately regenerate that schedule, with that new constraint in mind? And then seasoning and trends, anticipating different types of production changes throughout the seasons and looking at what if scenarios with respect to trends. Versus an ERP, as I mentioned earlier, ERP systems traditionally, they do look at your capacity in the sense that they do look at the resources that you have available for production, but they're not looking at real time, finite constraints. They're not looking at things like, did a machine go down? How long is it going to be down for? Is somebody sick? Is there a new vacation request? Things like that, where you need to input those new constraints into your scheduling system and have a new schedule generated around that new constraint. That's what an APS does. An ERP is not going to do that. And but an APS does work with an ERP, because an APS can pull your real-time order information and resource data that is held within the ERP that gives the APS the best possible data it can use when it does start doing that finite capacity planning. And so that brings us to why an advanced planning and scheduling system. And as you can see here, as I was mentioning prior, this is really going to affect your time to market. It's going to affect the quality of your products. It's definitely going to improve the efficiency with which you use labor and assets. Really matching supply and demand. Again, you don't have to build in these gigantic production buffers to account for huge disruptions to production, because you can just accommodate them as they are happening. And that's a huge difference between that and just saying, well, just throw so much buffer in there that, that literally everything has to go wrong before the schedule doesn't hold up. As we see here, you're going to detect bottlenecks in your production. You're really going to reduce your work in progress. You're going to reduce your inventory. A lot of these things that really hurt production, hurt profits, right? And so with that, that's a quick overview of advanced planning and scheduling software, how it relates to something like an Excel sheet or an ERP that you might be more familiar with. And with that, I'm going to kick it over to Marco to focus in a little bit more on how APS addresses these things. Marco?
Thank you very much, Philip. It is a pleasure to be here with you all, guys. I appreciate that. As Philip highlighted in the beginning, I'm Brazilian and English is not my first tongue, so I apologize in advance if I make some mistake, and I will make some mistakes. So at the end, we are going to have a Q&A, and probably you are going to, and we can take your doubts or emphasize or try again to explain you what we are trying to present here. So I'm going to start with, Philip gave us a very good overview of what is APS, where it fits, but I would like to introduce you to what Siemens has to offer as APS system. So we have a product called Opcenter Advanced Planning and Scheduling, or Opcenter APS, which is a range of advanced planning and scheduling software. We have different versions. All versions use algorithms to analyze and calculate achievable production schedules. And it does it considering finite capacity and balancing the constraints that you put in the system in the modeling process. More importantly, it allows you to generate multiple X scenarios, and this is very beneficial because multiple X scenarios allow you to make better decisions. And more importantly, everything else here, it is the fact that with a proper tool, you can do easy reschedule. I have a friend that says schedule is simple. You can do it in your head from your house to your position or to the factory, but a reschedule is something really dramatic. As soon as you arrive at the gate, probably the doorman is going to tell you, hey, look, that ship or that lorry truck that you were expecting with that material didn't arrive. So you start to make the reschedule in your mind, in your head, and things cannot go easy in that way. So Opcenter APS, it's part of a broad portfolio that Siemens provide. As you may know, we have been acquiring through acquisition, we have been acquiring different companies to create our unique offer as a manufacturer operation management. And all this is now called Opcenter, and we are going to focus today on the scheduling part. But all our solution, MOM products, they have a feed between the ERP and the shop floor and with the PLM. So in the shop floor, you have your machines working. So how you link what you have planned in your ERP and send it to the shop floor. A work to list? Yes, probably. But did you schedule it, or do you schedule it in Excel and then send this across the company to guide people on the shop floor regarding that? So this is the horizontal and vertical integration where a MOM fits, and as you can see, one of the activities of the manufacturer operation management is exactly the job, the most important job in my opinion, which is the plan and scheduling, production plan and scheduling. And if you have other system, or if you already have a ERP system, and if you already have a manufacturer execution system, that's awesome, because the best class companies use real-time production data to predict and synchronize operations. Those are the companies that have a better results integrating all these technologies together. And the reason is simple, because you can generate schedule anytime you need, considering all the pushbacks that happens during the day. As Philippe highlighted, we are not, we can have the best maintenance plan in the world, but machines, sometimes they break down before the preventive maintenance. So what is the consequence of that interruption in the production? What you are going to do? So that's leads us to the point why I believe detailed production scheduling is so important. Let's do an exercise, guys. And this exercise, it's very simple. I just have 3 products here, X, Y, and Z. And as you can see, we have the view of process of these operations here. The resources, all the 3 resources are available for now. But look, they only work 8 hours per day. So if an important customer call you at this moment and ask you when you can deliver that, I would like to know what would be your answer. So please type in your computer menti.com and use this code 303177 81, and then please give us your guess or your answer. And I'm going to populate the answer online. Okay. So we are starting receiving answers, which is fine. Come on, guys, don't be shy. Go to the app and give us some answers. 1 week, less than 1 week. So here are the results we get at this point. Say for you guys that answer 2 weeks, probably you are being safe in this moment. Less than 1 week, 1 week you are going to frustrate yourself and the customer. Less than 1 week, well, it is possible, but not without a lot of effort. And as you can see now, if I show you a Gantt chart, only two scenarios. If you start the production, remember the exercise that Philip showed us, how many combinations we have. So in this case, we are just changing which product we are going to make first. So if we start with X, we are going to spend 11 days to finish all the 3 products. And remember, the customer only accepts to receive all the 3 together. So in this case, 11 days. And if you answer 1 week, you are going to frustrate your customer. Less than 1 week, well, it's possible if you start to add overtime here, but it's going to cost you more. So in the second scenario, we just change which product we are going to start first, and it gives us 8 days. So 8 days is much better result you can deliver to, you can promise for your customer, okay? So I hope these highlights the importance of detailed schedule and how hard it is to answer this type of question with a proper tool. And a tool that really can manage this kind of thing, that's what I'm going to present you now. So at this point, I would like to show you what is the type of facility that we are going to see in the software, right? So in the software, we are going to see a very simple production for departments, for production department, different production departments. Each department requires or has different constraints, and this one that is color preference due the fact that we have setup times based on color. It is allowed to have overlapping between operations, and we have constraints of number of operators. The second department, dedicated resource, which is the dream of any scheduler or planner, because, well, we just need to pile up the work in the specific resource. However, if depending on the mix of production you have, you are going to have more demand for one resource and than the other, and it can disrupt your workflow. And in this example, the third department, it's full flexible, and this is the scheduler nightmare, because he needs to make the decision. And everything that we produce in these 3 departments go to inventory or stock, a warehouse. So in this part of the production, we are make to stock and waiting customer demand to finish the last phase of the production and send it to them. So this is the scenario we are going to see in the software in a minute. So in order to present you this exercise or this demo, I'm going to talk about 4 different things. First of all, I will start talking about what type of resource and process and production product configuration we can set up in the software. How can we add constraints to this data, to our database, before we can go actually create a schedule, try to optimize something and release that information to the shop floor. At the end, we are going to imagine that we are going to have a second, the following day, we need to update the schedule, and we receive a rush order, and we need to figure out how we are going to deliver that. So to start, I'm going to walk you through what is resources, products, routings, bill of material, and orders in Opcenter APS. Well, this is the software interface. Hold a second, it's here. So I'm going to maximize my screen. So this is the interface. All the data, I have already loaded the data here based on the picture I showed you before. As you can see, we have a table where we list our resources, and we have some parameters that we need to set up. For example, this resource here, I'm defined that this is a finite capacity resource, while in this other resource here, we have defined as an infinite with shift partners. It means that I can I don't need to worry too much about this type of resource. It is something I don't need to control, to have a fine control as the other resources here. Okay, so once you have the resource, you can organize these resources according to what you are going to see or how you are going to associate that resource to your operations. And here we have an example. In this group here, we told the software that 2 resources are available in this group. And when I associate this group to our operation, what I'm saying, I'm telling the software that both resources are capable to process that operation in this group. And I can give the freedom to the software to decide which resource to take. Okay, so that's the basic resource and resource group. Now let's have a look a little bit on the products, the table. As you can see here, we have a few products just for the sake of to make it easy to understand the example. We have finished products and we have intermediate products. I'm going to show you this line here. Just to show you a few things. So this is the product. This operation is whatever you need to call the operation name. But here is the important thing. I'm telling the software that I can pick up, or the software can pick up any resource from this group. And have a look in this field here. So this field tells us that select from the group. So really, I'm giving freedom to the software to select which operation to make. And that's it. And an additional information here is the process time. So in this case, the process time change according to the resource we are talking about. If I pick up resource 1, I can make 4 items in 1 hour. If I pick up for this operation the other resource, I only make 3 items per hour. So that's how we set up the data in the system. And of course, we don't need to enter this data manually in the system. We can import this data from other systems. And I'm very happy to tell you that we can use this in a future session to show you. But all the way that we can add resource, process, and configure the product allow us to generate accurate modeling that allows us to have a great and better results in terms of scheduling. Now let's add some constraints in this model. Okay, so I'm going to talk about setup times and other production restrictions like operators, skills of operators. We are going to talk about power or tools. We are going to also talk about a little bit about calendars and how we use materials as well as a constraint in our schedule. Okay, so back to the software. As you can see here, we have a table with secondary constraints. I have different operators defined here. These secondary constraints is going to give me the accuracy I need to generate the schedule. Okay. Some of these secondary constraints are associated direct with the primary resource. For example, in this case, the secondary constraint associated direct to that, it's operators. I always use one operator when I need to use this machine, and the power is also a constraint in this case, right? So this is the first part of the constraints. And we can associate these to the resource as well as we can associate that to the operations. In this case here, we have associate for operations a constraint saying that, okay, in this work center, I need to select operators based on skills. And in this case, I can choose between skill A or B, but have a look in these product and these three products here. I only can use skill B to perform this operation. And this creates some constraints in our X scenario, right? So the next level of constraints, I'm going to jump to the sequencer or the Gantt chart, the interactive board, whatever you call. I call this the sequencer, and that's it. The sequence is show us the resources, all the orders that we have imported or entry in the system, and as you can see here, in front of the resource, we have the capacity. And this blue area here tells the software that this area is not available or this period of time. So actually in this resource we work 5 days by 24 hours, but we don't work on weekends. On the opposite, on the other side, these 4 resources here, they work with 2 shifts per day, and they don't work on weekends. So that's the reason I have this calendar here. So let's say before we start, I'm going to add, because I just received information from the maintenance department that the resource 2001 is not going to be available. It's going to be on planned maintenance during this period of time from Monday 0 to Friday 0. Oh, God. AM. Sorry about that. So what I have done, I just block the resource here, and as you can see, I'm adding on the fly a constraint to do that. So now if I start to generate the schedule here, we need to consider that this machine or this resource is not going to be available at this point. Okay. So the other thing that we can evaluate before we start a schedule is we have a tool here called Material Explorer, and when we import all the orders and based on the bill of material and the material we have available in the Y and in the supply table, for example, here we have a supply table that tell us what I have at this point, at this moment, what I have available in stock and what material I'm going to receive over the over the time. Okay, so those are the materials, and they are going to impact in my schedule, in my production schedule, right? So the first thing I'm going to check in this case is if I have all materials available to make the production I need. So let's open our Material Explorer and see what we have. Well, as you can see here, based on our bill of material, we have created the link between the orders and the link between the demand and the source of that material. And we have a shortcut here to show us what is the shortage. So the system is telling me that no matter the reason, maybe it was a quality issue problem, but I will not have, or I don't have at the moment, enough material of this part to provide, to allow this order here to be processed. Okay, so this is important information because we can tell the supply guys to provide us with additional information, right? If they can subcontract this production, if you can replace those items for a similar one. So you, scheduler, can interact with other departments to solve a problem that, well, probably is not going to impact your tomorrow shift, but it's going to impact your schedule overall. Okay, so back to the scheduling. All these constraints modeling that we can add in the model increase the production efficiency through the detailed schedule. Now, what I'm going to show you is how to schedule using basic scheduling rules or advanced scheduling rules. And for each of these X scenario, I'm going to create a X scenario, save it, create a comparison, and then make a decision what I'm going to send to the shop floor. Okay, so very quickly, let's go back to the software. One of the things that I'm going to highlight first, so I know this operation here, this order here, this specific order, it's that order that the time change according to the operations we are using. So the length of this bar is going to expand according to the process time we have associated with that. So I'm just drag and drop here to show you that the operation increases automatically based on the process rate I have associated to it, or based on the off-shift period. Okay, so I'm going to leave that there. I'm not going to sequence manually. So what I'm going to do, I'm going to select the forward sequence, and to make a criteria or to use as a criteria, what I need to deliver first is what I have to schedule first. So based on that, I'm going to schedule forward by due date. As you can see, this is our X scenario. As you can see, we have all the links. Everything is related, but as probably you can notice, this operation here, for example, is in red in comparison with this that is in black. So this is a quick highlight that I'm not going to be able to fulfill the delivery date I committed with the customer. Okay, because the demand is here and I'm going to finish the operation here. So these are a very simple example of the sequence forward by due date. But maybe you are asking yourself, okay, why in these, there is, for example, between these and these, there is a gap here. Well, the gap is justified because this operation needs a material that is not going to be ready before that time. But even if it was ready, if I move, drag and drop it here, well, it could be done. Okay. Can I anticipate this? Yes. Well, that's fine. Let me see if my secondary constraints are set correctly. Yeah, they are probably yes. Yeah. For here, here it's example. If I drag and drop on one operation and I have a violation, the software tells me that I'm violating some constraints, and I can keep it as it, or I just can reschedule, repair this schedule, avoiding my mistakes. So this is a schedule repair that I'm going to show it to you again. So let's say this is the first scenario, and what I'm going to do, I'm going to save this schedule scenario with a particular name. Okay, hold on. Now I'm going to save it as scenario number 1. And now I can see I have some statistics about this. I can see, for example, the resource utilization. I can see, well, my screen is not big enough. So I can see a lot of data here to make the decision about this schedule. But what I want to show you is, okay, so this is my first scenario, and I have used the forward sequence. What about try to minimize the setup times in the first operation here and the first step or the first 2 resources? So to do so, what I need to do, I need to, for example, generate the scheduling based on APS scheduling rules, and I will define that I want to use a preference sequence schedule. In this case, the system takes a little bit longer to produce the schedule, but deliver a different result, as you can see. So now I'm going to save this scenario as scenario number 2. And based on that, I can easily compare the 2 scenarios. On the daily basis, it is easy for the scheduler to have a look in the statistics and make the decision which schedule to release to the shop floor. But sometimes in some companies, it needs to be sent to few people to also agree with that. So in this case, I'm just running a report, and as you can see, scenario 1 and scenario 2, different KPIs to evaluate, and then I can make the decision based on these 2. So the total setup time, for example, in scenario 1, it's dramatically bigger than in the second scenario. The on-time delivery is, even if we are using better the resource, it's not helping us to improve the on-time delivery. So which one should I take? So despite the number of on-time delivery, the delivery delay is important as well. So in the second scenario, I have a smaller on-time delivery, but the delivery will be smaller than the first scenario. So what I'm going to do, I'm going to select the scenario number 2, and to do that, I just need to open the scenario. and release these to the shop floor. And how we can release this information to the shop floor? Sorry, I didn't save properly. Let's open the scenario 1 now. Now I need to save this as a schedule, which is the released one. So with this, I can send back this information to the shop floor. I can send these back, I can send these back to the MES system or the ERP system, or I just need to send a work to list to the shop floor to indicate for each resource what they have to do and in which sequence. Okay. So with that, I think I cover the base scheduling rules and the scenario comparison. As you can see, it's quick to adapt the plan change and needs, fast and optimal scheduling for multiple scenario, material flow analysis, all of these to allow you to make better decisions. So the last use case is I'm going to consider that in the following day, okay, we have to update few operations and we have our order inquiry to respond. So let's go back to the software and see what we can do. So this is the released operations, okay, the released schedule. So tomorrow, let's say that now it's tomorrow, what we have received here, this is what we call terminator. It's going to move forward, and at this point, with a quick zoom on that, say I would expect that this operation is finished, this operation is still running, this operation is finished, and so on. So I can import this information from other system, or I simply can update this information right here. So doing so, saying that it is being executed as forecast or as predicted, I don't need to worry about anything else. So I'm just locking the operation that has started but not finished, and if I need to repair something here, it is fine. However, what I'm going to do here is in this operation, I want to tell the software that we have we are not performing well. So basically, we have started, it's running, and at this point, oops. At this point here, at 7 in the morning, I just did 100 items. And what is going to happen here, it is the system is going to update the performance here. And if you didn't notice, this operation is going to finish earlier than expected if we keep this pace. So have a look. It was finishing here, and now because we update with the software, we put the information that we are executing faster than this, I can anticipate I have a gap here. And how to fix that? Well, I don't need to generate another schedule. I can simply maintain the sequence when possible, but allow operation to be scheduled earlier. And that is our schedule repaired based on what we have updated in terms of execution, right? So it's quickly, it is fast, and allows you to send back this information quickly to the shop floor. Now, let's say that we receive order inquiry, and the order inquiry, the customer is like the exercise we did. This is inquire. I'm going to use like this. A customer is asking us if we can, when we can deliver this product, 500 units of this product, and what I'm going to do, I'm going to hit OK, and the system will evaluate what is available, if I have the raw material, if I have everything in place, and then show what we have to show here. Okay, so this is like this, guys. So without to disrupt the previous schedule, I can promise the customer these dates. Okay, so that's the scenarios I would like to cover with you today. So as you could see, we can really adjust the plans easily and quickly, and we can use and share these expertise across the company. Okay, so Philippe has shown us a slide, similar slide on this. The difference here is the value drivers in our company. I put some metrics, and these metrics are from real case studies. So, for example, we have, well, Siemens is a big company, and before we sell software, we are in the market for 170 2 years or longer, I don't remember, but we use the software we sell. So this is the case study from the gas turbine facility, and those are the outcomes that we achieved after the deployment of this solution. The other case we have here, it's a very small company. So Siemens is a big company, but this company here, based in the US, is a company that make 2 million revenue per year. So it is a really small company, and the software will help them to increase revenue or on-time delivery, and output has increased as a consequence of that. This is another type of, another example, very good example, 20% increase in capacity. Man, how to get that without add a machine or a resource? So it's down to the scheduling bit. We have, if you are in the aerospace and defense, we have customers in this area, and Proform is a very old customer of ours. They have increased in 96% increase on delivery time. They multiplied by 20 the workload, so they increase the resource utilization, and probably they are making more than they were making before. So it's another example here. This is a Brazilian company I know. They make plastic material for constructions, and as you can see, they went from 47% adherence of what they schedule and what they real produce to 45%. This is huge. The adherence of the schedule to the shop floor means that the shop floor executing exactly what was planned for that. Okay, so we have, as a consequence of that, a reduction of 50%. This company is a beverage company, alcoholic company. You probably have tasted. It's a cognac, and as you can see, also outstanding outcome after the deployment of the software. And the last one is a food company. So all these examples here is to show you how the software is flexible to be adapted and configured to different type of productions. and everyone that follows this path achieve great results. And with that, question and answers.
Thanks so much, Marco. Yeah, it looks like we've got a couple minutes left. And so if anyone has any questions, feel free to put them in the chat box, or feel free to just open up your mic and let us know. We covered quite a bit of ground here, but yeah, any particular use cases stand out? Any questions you have about this software and how it can add value? Any takers?
Shy people, Philip. In Brazil,
Absolutely.
we'll have a lot of people asking things. Well,
yeah.
Especially about Mattel.
So Marco, when it comes, like, when you see people adopt this solution, what would you say are some of the like the quickest wins? What are some of the things like you see within, let's say, a 2 to 3 month timeline, if you're looking for that immediate ROI?
Yeah, well, the first thing is when we start deploying this software, it's not just a software deployment, right?
Mm-hmm.
Because you need to understand the bill of process, the bill of material, and check if you are scheduling according to what can be really executed in the shop floor. So
Right.
so if you download the bill of material or bill of process you have in your ERP system, the first schedule generated based on that information probably is very bad, because the bill of process usually designed to help companies to calculate cost, while it's not a very fit for scheduling details. Because again, detailed schedule is being done by someone very clever without holidays and using spreadsheets. So during the implementation process, the first benefit is start to align all the different departments with a new mindset and a new type of data that is going to support the scheduling initiative.
Mm-hmm.
Okay.
Yep. Yeah, so I mean, like, when it comes to, like, I mean, one of the things obviously with APS, right, is like people hear production scheduling, right, and the first thing they think of is like, well, I think the first thing a lot of people think of when they think of APS is, in production scheduling is, well, we just sank so much money into our ERP, and we were told that it would handle our production scheduling. Like what are some things, like, when we get into like the finite capacity or like doing changes, like what is the ERP just not going to handle? Even a pretty decent ERP.
Well, a lot of things like setup times, for example, is one of the things that it is quite difficult to handle in the ERP system. And usually they have fixed setup times, and in Opcenter APS we can handle matrices. So from one product to other product, we can differentiate the amount of hours that you need to spend preparing the machine to perform the next operations. So this is one example, and there is a lot of other examples in this situation.
Actually, sorry, Marco. I just want to make sure, we did get a question from the audience, so I want to make sure that takes priority over mine. So I just want to kind of, it actually probably is related, right? But can an APS system, Marco, get data from the plant floor, from the shop floor in real time, right? Like when it comes to things like downtime, cycle times, like can it pull that data in real time?
Yes, absolutely. And this is one of the benefits I have mentioned at the beginning of my presentation. If you already have a system that provide you with what is being executed and how it's been executed, when you link this with the Opcenter schedule tool, you can react and anticipate problems. For example, if you have a breakdown, a downtime, and this downtime is you call the maintenance guy, and the maintenance guy say, okay, I will need 7 hours to work on this and fix this machine. So at this point, the scheduler can take can add this constraint into the scheduling board and say, for the 7 hours, we are going to stop the production for this item. And what is the consequence of that? That's the value of this solution. And to continue, okay, Alan Douglas is asking, can they schedule automatically regenerate and update schedules autonomously?
I love this. I love this question. Basically, can it be an organism that that is that is automatically connected to the real-time conditions and making those updates autonomously?
Yes, but I have to be honest with you all. This is not the first goal. It can be done, but it is a journey. First, you need to generate feasible, accurate schedules. Then the shop floor starts to follow up that schedule, and you have to have a high adherence of the execution compared with the plan. And then you start to figure out what is the type of event that you are going to receive from the shop floor that really triggers the software to automatically repair the schedule and release another work to list to the factory. So the short answer for this is yes, we can do that, but with my experience deploying the software, it's not something that you achieve in the first wave of the project.
Yeah, I mean, my guess would be that the kind of step you would do before that is you would get to a situation where you're getting the real-time data back from your shop floor. You're being alerted when something changes. Yes. So like, late arrival of material, like you're being alerted about things in real time, and then you're running a manual refresh or repair. That to me would be the stage you would do prior to going full like set it and forget it type. Yeah.
And this is important, what you said, Philip, because this is why during this period of time, we learn, and the software also learn what type of output it needs to present based on the event that is being received from the shop floor. So it is, we have some customers worldwide, including Brazil, that is using autonomous scheduling.
Yeah. And I think a third part here, Mark, you can probably see, can it schedule for batching operations?
Yeah,
like
for sure.
Like part runs on a series of stamping presses. Yep.
Yes. So everything it's dependent on how you model the solution, but definitely yes.
Mm-hmm. Yep. Absolutely. Yeah, okay. I really appreciate the questions, Alan. So we're 5 minutes over time, and we appreciate you all for sticking around. But yeah, if that's good for everybody, I'm going to draw this to a close, and thank you all for being here, and thank you, Marco, very, very much for helping us out here today. As I mentioned earlier, we are recording this, and so we will make the recording available to everyone who attended, and so you'll be able to have that for your future reference as well. You'll get a recording of this webinar. So thanks, everybody. Have yourselves a good day.